Hello everyone, I'm Aditya, co-founder of Adirani Digital Solutions. Today I'm here to discuss more about the fundamentals of app development. And this is a perfect course for someone who is a startup founder. You don't need to know anything about coding, you don't need to know anything about like literally computer science things, not even how apps are built or everything, because that's why this course is here. This will cover everything at a very basic level, which will cover about what you should expect, uh, the pros and cons, and many things that like the stages involved in software development and many much things that will help you as a startup founder to build scalable apps. In this course, we will see first the introduction, like the basic of software development. Then we will see the key stages involved. Also, we'll look at the terminologies like front-end development, back-end development, and everything that you need to know as a startup founder. Then we will see some technologies options like Firebase, AWS, and other tech stacks that could be used to create any scalable app. And then we will see how you can use modern technologies and create a scalable app, whether an MVP stage or ready to market stage, and have some cost cutting. Now, you might have a question as a startup founder why you should know about app development. Like, what's the purpose of it? Why can't you just hire someone and have them have all the control over it? Well, the main thing is you need to understand as you're a founder, so you would be there to bridge the gap between your tech teams and your non tech teams. So, having this basic understanding of how apps are developed, it becomes much simpler. Then you can also use it to make some informed decisions like how much cost to involve to put in that or what resources to use and so on. Also, when you have control over it, you can make those app or whatever you're building up have reached faster to the market, have it reach in a much faster time. And also you can have control over the cost. And the most important thing is if you are outsourcing it, no one can fool you off and just say, okay, I'm going to make you a product which is of 1K and charge you 10K. So to have these, all the understanding based on our experience, how things work, we have created this course which will cover all of this and help you to make a good informed decisions. So generally in application development, you have 5 key stages. Now this might differ from organization to organization. Sometimes you might say it's 6 or 7 maybe, but generally you will have this generic stages. So it begins with you have an idea, maybe on a piece of paper or somewhere in ideation phase, and then you scope it out, you have some research done on it, you have your target audience, all the requirements are gathered, and once everything is done, once you have like a solid plan, it is then given to a designer. So maybe they might use some tools like Adobe or Figma or some kind of designing tools to create the prototype of that app. Now, once that prototype is created, it could be like a mobile version or a website version, or it could be just one of those or both of those, whichever it is, that is given to a developer. Now, generally, you might outsource this or you might have an in house team, and this prototype is used to create your app, which could be using some tech stack, some programming language, or some no-code tools like Bubble, or some CMS like WordPress, or anything your developer would prefer. Now, this stage is very crucial because once it's in this development stage, there might be some iterations from the designer and the developer. So there might be some iterations happening here. Once you have your prototype, your app prototype, that is then passed for testing. Now, in a startup, let's be honest that we have just one person doing all these things, or there might be few people doing all these things. But if you have a team or outsourced it, then the testing team or the person in charge for the testing will make sure that all those bugs or all those major bugs are found before your user finds it. So this might again require some to and fro between the developer and tester. And finally, your app is deployed on some cloud platform or some self-hosted platforms, and then start with the maintenance stage. And whenever you have a new feature, this cycle repeats again. So this is more like a basic cycle where you have planning, where the ideation is done. Then you have a design where you have some prototypes created or wireframes created, given to the developer. Then they will test it, and finally that will be deployed. Now, to see it in a diagram, you will see a cycle like this. Now, generally, uh, it's very difficult to get out of this loop especially when you're creating an MVP. So, how to make sure that you follow this cycle and at the same time, things are done in an agile way. So, generally, like what we do is we generally have like 3 key features for our MVP or X number of features. Generally, they are less than 5. It goes through this cycle. As soon as it's ready, deployed, went out, and then the next features. So main key features goes through the cycle, and that's it. So it becomes much, much simpler. And also, you can have control over it because if something goes wrong, it's very easy to rectify or it's easy to roll back. But if you have like lots of features or lots of things happening there, then it becomes very difficult to roll back or it becomes very difficult to manage all those things. So the key thing here is to make sure that you have not exactly less than 5, it might become sometimes 6, but as less or as optimum as possible key features, run through this cycle, and then the next features. Now, next we got some terminologies which might be scary for some of you, or some of these you might have heard like or seen for first time. But generally, when it comes to software development, we have like these 5 key terms again. Again, you might have many, but these are, you can call it more like the 5 pillars of that foundation where your software stands on. So here we got the front end, which is generally the UI of your app or your website. If it's a website, it will be only created using languages like HTML, CSS, or JavaScript. If it's a app or a mobile app, then let's say if it's an Android app, then it will be created either in Java or Kotlin. iOS app will be in Swift UI. Generally now there is a people prefer hybrid apps which are generally done with Flutter or React Native. And going back to the website part, mostly you will see people using frameworks like React, Vue, or Angular, or Svelte, or some kind of JavaScript framework or libraries to make it much, much simple. Now, these technologies, like especially the front-end technologies, you might get a developer who knows all of these, like backend and frontend both, or you might get a developer who just knows like just the frontend or the backend. But that's not a problem. The main thing here is that once your front end is ready, you might have your backend in the same code base. Let's say there is a term known as monolith, which means like everything fits in one ecosystem. So you might use frameworks like Laravel, you might use framework like, which is a PHP framework, or you might use framework like Ruby on Rails, which is a Ruby framework, or you might use frameworks like Spring, which is a Java framework, Express, which is a Node.js framework. So those frameworks, or Django, which is a Python framework, those frameworks allow you to write the front-end logic within themselves. So it becomes like one thing holding everything. And you have your backend, which is generally responsible for creating that magic. So to give you a basic example, like how this works, let's say you went into a restaurant, you will be the customer, so you are the UI or the front end of that restaurant. The kitchen is the backend where all magic happens, and the servers who serve food, they are generally APIs, which we'll see in a moment, like how things work. They will make sure that the communication happens between the front end and the back end. So another simple example is when someone's login, the data is captured using these technologies, HTML and JavaScript. CSS is mostly for the UI or more like showing the beautification of it or just to make it prettier. That is sent back to your backend, which is generally written in one of these languages. And your backend will process that logic and or data, send it back to the front end. So the communication happens between these two. Now, when it comes to the other part, like databases and server, definitely your front end cannot directly communicate with either of these because these are made in a way which, if they're exposed, then it might cause a lot of security threats. And the best way to do it, or how it is done, is that you have a backend server or a backend logic, generally called as a business logic or application logic, that communicates with your database. So if I show you a diagram quickly, so you got your UI over here, then you got your business logic over here, which is generally written in one of the server-side language like PHP, Java, Python, Node. Node is again like JavaScript on server, so that's why it's called Node. And this is responsible for making, like you can treat it like call it like an agent which acts between like an agent of communication for front end and your databases, file storage, and all other services on the server. Also, you might have, let's say, a third-party service, let's say Stripe, which is used for payment processing, or you might be using some AI feature from OpenAI, or uh, Anthropic or somewhere, that communication can also happen directly either from the front end, or the best way to do it is to make it happen from the back end, from your server side logic, because this is something which is which you have complete control over. Because if you like, the only way to access this is to get inside your server, have passwords and everything, and get access to it. But getting access to your front end code, it's not a big deal. Anyone with a simple understanding of HTML, CSS, JavaScript might just open your website, see the JavaScript code, how things are done, and get, I won't say a lot of information, but good amount of information, and understand how things are done in your website. So anything secure, anything confidential, anything that needs like high security always happens on the server, or any computation or anything related to databases or transactions or anything always happens on the server. Now, going back to this, we have databases. Now, database you can consider as an electronic records, or digital records. So they are stored on computers or on servers. The servers are nothing but computers placed remotely without monitor. So even your computer can be a server, depending upon, let's say, if you have an office, you got your computer placed there, and if everyone connects through your office connection to your computer, then your computer becomes a server. So databases, they got their own database servers, so they make sure that the communication happen through the backend to the front end. So we got two types over here, SQL and NoSQL. So SQL stands for structured query language. Now this NoSQL doesn't mean that there is no SQL at all. It just means not just SQL. So SQL you can consider more like Excel spreadsheets, which are like tabular format. You have rows and columns, and there are some relations between each table. So it's very good for creating a relational database. NoSQL, on the other hand, is more of like unstructured raw data, which is either document oriented or key value pair oriented or JSON, all those kind of things, or even files, videos, all those things are NoSQL data. Now, generally in an app, you will start with one of these, either SQL or NoSQL. Generally, people start with SQL, but again, it depends. And then you will have the other one. So if you start with SQL, you might need NoSQL further down the line. If you start with NoSQL, you might need SQL further down the line, because these two are needed to create a solid database ecosystem. To give you an example, let's say we got an e-commerce website. So we got products, we got orders, we got customers data, a lot of things happening there. Now, when it comes to storing this data, you use generally SQL database. You can use NoSQL database, there's no harm in that, but SQL database are really good when it comes to relational models, because you've got products, they're associated to categories, so there is a relation between that. Every order is associated to a product, and customer as well, so relation between that. So when you have a relational data like this, SQL is a very good option. Now, what if you need caching, or you need to cache that data? Caching is just a temporary memory where you can store data so that it becomes faster to access and it's much faster in performance. So what if you need something for caching? So in that case, you will use NoSQL, because it allows you to store such data, and there are very good options out there as well. We'll see further down the course what options are available for SQL and NoSQL. But suffice to say that you will use both of these rather than using just one of this. Now, once you have your front and back end databases, it's best to use something known as a framework. So frameworks are nothing but, consider that someone out there did all the hard work for you so that you can use that and create your app on top of that. So to give you an example, if I have to see a framework for PHP, then there is Laravel, there is Symfony, there is Cake PHP. For Ruby, there is Ruby on Rails. Node.js, there is Express. For Python, we got Django, FastAPI, Flask. For Java, we got Spring Boot, Spring. So these frameworks are generally, they generally have all that logic, or the basic logic that you not need to write again. For instance, security, connecting to database, or making sure that the requests happen faster, making sure that the response gets in a better way to the from server to the front end. All that logic, the security aspects, the performance aspects are generally taken care by the frameworks. Also, when we talk about the development side of it, the code reuse or the code written is kind of managed by the frameworks. So generally, you'll use a framework. It's same for mobile application as well. For hybrid app, you have React Native or Flutter, which are very good frameworks for creating mobile apps or hybrid mobile apps. So generally, you'll use one of that. And then we got the server. As I said, it's just a computer placed remotely. So you might use a server, let's say AWS, which is Amazon Web Services, Firebase, or even on your own server or Google Cloud Platform or some kind of server, which is nothing but a computer placed remotely and all your code resides on that computer. So here I have some activity for you. You got 10 minutes. With that, you need to mention three technologies for website or web development, one technology for mobile app, one for databases, one for hosting, and one for no code. Now here I've given some examples, so you can ignore those. Don't count them as your answers. So we also saw some technologies in the previous slide. So based on that, just try to categorize those technologies in each of these categories. After seeing the frequently used terms, which is front-end, back-end, databases, frameworks, and servers, now let's see some technologies that are generally used to create an application. Now, when it comes to websites, you will see people using either React, Vue, or Angular for the front end, which is just a JavaScript frameworks and libraries to create amazing UIs, or you could say like that front end, which makes it much easier to have that user experience. So example is, let's say Netflix, it uses React, Amazon Prime, it uses React. They do use other technologies. Then we got OpenAI website created with Nuxt, which is a Vue framework. So there are many examples like this. Now, if you want a complete package where you want to create a website where you want the front end and the back end functionalities in one package, then we got frameworks like Laravel, which is a PHP framework. Then we got Nuxt, which is a Vue framework, but also it uses Node.js for the backend. We got Next, which is a React framework, so it uses React for the front end. For backend, it uses Node.js. We got Ruby on Rails, which uses Ruby Express for Node. And if you just want to create, let's say, API services, or you have a software as a service product and you just want to have APIs for your product, you can use either Laravel, Express, Fast API, Spring. Spring is a Java framework. So Fast API is a Python framework. So these technologies, they're very robust and very well developed, and all of them are open source. So there's a huge community out there. So if anything goes wrong, you can always, or your developers can always ask questions to the community, get the answers. And the main thing that we have noticed using this framework is that even though it might take time to develop, let's say it might take more time than using a no-code technology, which is not a wrong, like there's nothing harm in using no code, but it's more like when you have an idea which is very scalable, which needs more bespoke solution, then these technologies are very preferred. And they give you a lot of control over to when you create your app, so you decide how you want it to work. And also it's much, much simpler to achieve that performance or avoid those performance bottlenecks. Now for mobile app, we got Java or Kotlin for Android, we got Swift for iOS, then React Native and Flutter and Ionic for hybrid apps. So what are the hybrid apps? So when it comes to native apps, that means if I create, let's say, an app in Java or Kotlin, it will only run on Android. It will never work on iOS. If I use Swift, it will only work on iOS. It will never work on Android. What if I want to create an app which works on Android as well as iOS? Because when it comes to mobile application development, it's much costlier compared to website development. So there is a technology which is hybrid applications. That means you write code once and have it work on multiple platforms. So let's say if I create a mobile app using React Native, it will work on iOS, it will work on Android, and if someone uses Windows Phone, it will work on that as well. So same for Flutter. So React Native is literally React for hybrid applications. So everything is same, like it's literally JavaScript. Everything is same. It uses React logic. Only certain few things are different because, of course, here you're creating for mobile platforms, or for all the platforms here, you're creating strictly for the web platform. So there will be some differences. Flutter uses Dart, which is a programming language. Ionic is a JavaScript framework again, so you can use Vue or React or anything and wrap it with the Ionic framework and have a mobile app. So these technologies are generally used to create mobile applications. Oops. Then when it comes to databases, So generally, as I said, like you will have either SQL or NoSQL database as a starting point, and on top from there you will get the other part. So if you start with SQL, you might have NoSQL further down the line. If you start with NoSQL, you might have SQL further down the line. Depends. So if you want some SQL options, then we got AWS RDS. Now the thing about AWS when this video is recorded is that it got 1 year free tier. After 1 year, you get charged. Based on our experience in the free tier, we were charged like $1 max. But for a medium sized app, we were charged around $150 to $200. So that price per month. So this price might differ for your app. It differs from service to service, but roughly you can expect that charge. So AWS got a lot of resources for cloud computing. It got RDS, which is a relational database service. Then you got Elastic Beanstalk for hosting your app. You got EC2, which is just Elastic Cloud Computing, which is just for hosting your app again. So it got lots and lots of services. It also got serverless options. Serverless means that you don't have to worry about the updates. You don't have to worry about managing or upgrading the softwares and everything there. All you have to do is deploy your code and everything is managed for you. So serverless are very good. The only problem with the serverless is that they have cold start. For instance, let's say if no one visit my service for, let's say, half an hour, the serverless service shuts down. And when it has to start, it has that rebooting time again. So it has that cold start time compared to serverful, which are like Elastic Beanstalk and EC2, they are serverful. They're always on. So whenever the request comes, they just respond to that request. So serverless platforms are really good as well. AWS also got good some options. It got Lambda, Lambda Edge, and also Amplify. Then we got Firebase, which is a Google service. So Firebase is it's actually a cloud platform, plus it provides you all the functionalities from the backend perspective that you need to create an MVP or a solid scalable app. So it has authentication service, it has the database service, or actually just NoSQL database. It got all the APIs that you could use, or all the libraries or functionalities that you could use, and literally just use that code and have modified to a certain extent and have it used in your app. So using Firebase, it just reduces a lot of overhead when it comes to creating the backend of your application. So if you want a SQL version of this for Firebase, there is Supabase. It uses Postgres SQL database. Then we got MongoDB, which is a NoSQL database, DynamoDB, which is by Amazon or AWS, NoSQL again. When it comes to caching, we got Redis and PlanetScale again, which is a MySQL database as a service. So these are just few options out of many out there. And these options, some are very cheap, but they are pay-as-you-go service. So more you use, the more you are charged, while some are like free and then you will be charged afterwards. So it depends upon your application, your problem statement, your circumstance, and based on that, you can make informed decisions on the services that you want to choose for your database. And when it comes to hosting, we got AWS, as I said, it got Elastic Beanstalk or EC2. Firebase hosting, it's literally like, so we got our own website on Firebase and we literally pay nothing for the hosting because it's serverless. And of course, if the traffic is huge, like huge, you might pay a lot of money. So if it's a starting point, if you have, let's say, if you don't expect much of a traffic, then Firebase hosting is really good. Then for a no-code options, we got WordPress. If you consider this as a no-code, or I would consider it more of a low-code, Wix, Squarespace, Bubble. Again, Squarespace was typed twice, sorry for that. So these options are really good if you want to create a website. Now, what if you have a marketing person who is doing your website, managing the content of the website, but also your website has, or your application, your web application is a bespoke application. It cannot be done with these technologies. You need to use one of these technologies. So what you could do? Generally, from our experience, we have seen when we did our client projects for most of the startups in UK and also some in India, what they did was they will have a website created in either one of these no-code technologies, which is generally called as a marketing website, and their app will be on a subdomain, like let's say app.example.com. But there is a much better approach, which you can use you could say like best of low code as well as full code, and have your app created where you can have like a bridge between your tech team and a marketing team. For that, there is a technology which is headless CMS. So how it works is your app is generally created with one of those programming languages like or one of these tech stacks over here, and then you use a third party service generally known as a headless CMS, which provides you a dashboard to manage the content of your application or your platform, and that content is pulled using their APIs. So some example of headless CMS are Gerchi CMS, this is our in-house CMS, Sanity, Strappy, all these CMS, they're very powerful and they have very good solutions to create bespoke contents for your platform. Now, I use this term API a lot. So what does it exactly mean? So going back to that example of restaurant, customer is the front end, the kitchen is the back end, and the person or the people who serve food, they are the API. They get the food from the back end and give it to the customer, which is the front end. Now, in a software terminologies, APIs are nothing but, you could say, that piece of code or that piece of software which connects one software to another or one software to another hardware. So they are generally used so that you can reuse the code, you don't have to write that code again, and just the communication happens smoothly. So these services, like Stripe or any other service out there as a third-party service, they have their APIs, which will allow you to fetch the content that you have created using their applications or their app or their dashboard, which is literally like could be used by anyone who don't know how to code. And then that content could be used or consumed using the API that are generally written in one of these languages by your developer. And then you can create a scalable app without need to have a subdomain, or you can have everything under one ecosystem. Now, the main question, how can you do cost cutting? Or how can you make sure that knowing all these knowledge, everything about whatever we have talked so far, how it could be used to create a resourceful application, or how it could be used to have that bridge between a tech and a non-tech team? To begin with, we need to understand that cost cutting doesn't mean that you are spending less, but it also means that whatever time you're putting in that development process, it is used effectively. So it's all about achieving result in the most resourceful way as possible. Now, here we have an example about outsourcing versus in-house. So generally, as a startup, you will outsource your project to someone, uh, maybe an agency or maybe a friend that you know, or you might just have some investment and you just have a team in-house. Now, both of these options have their own pros and cons, and depending upon your circumstances or the application you're developing, each option has its own power. So here, when it comes to like this, again, is a very rough estimate. It's not like the final answer to everything. So here, let's just assume that we got a 3 months project, which is running on an average, and it's just a project for creating either a web app or a mobile app, something like that. So if it's a web app, generally for a 3 months project, you will, if you go with outsourcing, you will be charged around 10 to 15K, roughly. Again, this can be less, this can be more, depending literally upon what software you're asking them to create. If it's in-house, you might get a developer at a salary of 3 to 5K per month, or you might get 2, 3 developers where you'll be paying their salary of around 3 to 5K per month. There will be other costs like their hiring costs, their insurances, or anything that you as a company need to pay. So there are other variable costs. And then we come to the advantage, like the main advantage of outsourcing is that you got cost savings because all these things, that other variable costs, you don't need to manage. On the other hand, the main disadvantage is that you have reduced control because that company working out there, they are not your employees. They are just, you could say, like a contractor or subcontractors or some team that you have collaborated with, and they decide most of the things. So it might not be good if you want complete control. In-house team has direct control, like you decide the rules. Everything is managed by you or some person that you have hired to manage them. So there's a lot of control, or you directly have complete control over it. However, there are costs involved, like, as I said, these other variable costs that might increase over the period of time, or they might be low. So as I said, like these things are very, very rough estimates. Now, how this knowledge, like whatever we have learned so far or whatever we have seen so far, can be used to act as a bridge between a tech and a non-tech team. Now, whenever you have a tech meetings, as a startup founder, you might be involved in it, and when these terminologies are used, it might help you to understand like what is expected at the end of the day, or what you could expect them to do differently, or any suggestions that you can make. So in this way, you have a good amount of control over the team. You can make informed decisions, and also you can make sure that everything is done in the most resourceful way as possible. Right. So that's all in this course. I hope you enjoyed this content. I'm Aditya. See you again.